Hi, I'm Tom, coming to you from the International Institute for the Advancement of Sourdough Science and Research of Cleveland, Ohio, also known as my kitchen. Thank you for selecting this video. Today's video is a continuation of the series, When is Bulk Fermentation Done? This is the 6th episode in this series where we help beginning sourdough bakers determine the answer to this most complicated question. In episode 3 of this series, we introduced a tool called the incredible Bulk-O-Matic system. This is a 9-factor system that we use to determine when bulk fermentation is done. If you haven't seen one of the episodes yet that uses this tool, I recommend watching episode 3 first. This is a tool we developed here at the Institute, and we use this in all of these videos now. Now, today's video is a continuation of what we did in episode 5. If you haven't seen episode 5, what we did was we baked 4 loaves of bread with different leaven percentages to determine what the impact was on bulk fermentation time. It was a fascinating experiment. We baked 4 loaves of bread, starting with 30% leaven, 20% leaven, 10% leaven, and 5% leaven. They bulk fermented at different speeds based on that different leaven percentage, and we cut them all off at what we presumed to be exactly the same point in their fermentation. And when we cut the loaves open at the end, all 4 of those loaves looked almost exactly the same. So it was a great test to show that you can speed up or slow down your bulk fermentation time by increasing or decreasing your leaven percentage without impacting the ultimate outcome, which is the crumb and the shape of your loaf. Now, in that prior video, although the results were fascinating, the bulk fermentation times all took longer than expected. And at the end of the video, I surmised that this is because my starter was weak and I created a weak leaven with my starter, and it caused all the bulk fermentation times to be elongated. So in today's video, you get a 2-for-1, 2 topics today. First, I'm going to show you how to refresh and strengthen a weak starter, and then I'm going to repeat the same experiment, 30% leaven, 20% leaven, 10% leaven, 5% leaven, with what I believe to be a much stronger version of my starter. So comparing this video to the prior results, we'll be able to compare the impact of using a weak starter on bulk fermentation times versus a strong starter. So as I mentioned, I was unhappy with the results of that prior video, and I wasn't the only one who was unhappy, because as soon as I published that, I got a call from the board of directors here at the Institute, and before I knew it, I got called into a sit-down meeting in the boardroom here at the Institute, and I had to explain what was going on with my starter because it was impacting the outcome of the experiments. And I tried to explain to the board that my starter was weak. It's the middle of winter. It got a little sluggish, and I called it lackadaisical. I quickly regretted using that term to describe my starter, because then the board showed me some footage from our security cameras here at the Institute, and all I can say is it wasn't pretty. So in all seriousness, what happened is I was just neglecting my starter. I got involved in another project over the last month or so. I wasn't doing my daily feedings on a normal schedule. I was skipping days here and there. I would feed it in the morning one day and the evening next day, which was, 36 hours later. And in some ways, I just got a little cavalier with my starter. I had had good success with it, and I started to think that it was invincible, that it didn't need daily feedings, that it was so strong it could handle anything. And that really wasn't the case. I actually deteriorated the strength of my starter just through an infrequent, neglectful feeding schedule. So this reminds us of the first rule of sourdough baking, is that You don't make the bread, the starter makes the bread. So you need to show your starter a little respect. So in part 1 of this video, I'll show you how to strengthen a weak starter. And in part 2 of this video, we'll do the 4-loaf experiment with the different leaven percentages. So part 1, how do you strengthen a weak starter? The first question is, how do you know if your starter is weak? There are 2 real simple tests you can do. The first one is that as a general rule of thumb, your starter after a 1-1-1 feeding should double in volume in about 4 to 6 hours. So once you mix up and feed your starter, you should see it double in height if you're using a straight-walled vessel like this in 4 to 6 hours. That 4 to 6 range really depends on the temperature. If your room temperature is low, say 72 degrees Fahrenheit or 22 degrees Celsius, it might take 6 hours. If your room temperature is warm, say 76, 77 degrees Fahrenheit or 25 degrees Celsius, you should see it doubling in about 4 hours. Here's an example of a video I took of my starter when it was very strong. And this shows it more than doubling in 4 hours with a slightly warmer temperature, as you can see on the thermometer there. So you can see in that video what a strong starter looks like. My starter just wasn't acting like that. I would feed it and it just wasn't rising very quickly or with the vigor of what you saw in that video. The second test is really to compare your bulk fermentation times to known bulk fermentation times in known recipes. So I use the tartine bread basic country loaf recipe. I make that bread all the time. I try to have my target bulk fermentation temperature at 80 degrees Fahrenheit, which is roughly 26, 27 degrees Celsius. At that fermentation temperature, it usually takes about 5.5 hours from when I initially mix the dough. In this example that we did in episode 5, it took 8 hours for the dough to rise, the target 30% rise. So I could just tell based on my experience and based on the standard times that I just wasn't hitting any of the standard recommended times. The only reason for that is that your starter is weak or your leaven is weak. I'll use the term starter and leaven interchangeably throughout this video. So once you determine that you have a weak starter, what do you do to strengthen it? Now I have a whole separate video called How to Strengthen a Weak Starter that talks about how to assess your starter feeding cycle. It shows the curve that your starter typically follows as it rises and falls, and it gives an example of what your starter should look like in each one of those 7 phases. And then I talk about recommendations for how to strengthen a starter. In today's example, I'm actually going to do it. I'm actually going to show you what I'm doing with my specific starter, and it's a combination of a lot of different recommendations from that prior video. So after my conviction on gross starter negligence, I was sentenced to 6 days of solitary confinement with my starter, a bag of flour, and a bucket of water. I was committed to turning things around to try to redeem myself and my starter, and after 6 days, I'm happy to report that it worked. After 6 days, my starter was overflowing from its vessel. It could not be contained. It could not be constrained. It is the strongest starter I've had since I started sourdough baking. In 6 days, it was an amazing turnaround. Now, if I showed all the steps, it would take an hour to do this. I'll probably make a separate video on this topic. But what I'll do here is show you the highlights of what I did each day and show you the key things that I accomplished. It was really quite amazing because I didn't have access to rye flour. I didn't have access to a proofing box. There were no tricks. There were no gimmicks here. All I did was change the starter feeding ratio and the starter feeding interval. That's it. And in 6 days, I completely turned around the starter. I more than doubled the strength of the starter. So on day 1, I started with my existing starter, Callie. This is the starter that I used in episode 5 to make those loaves. This hadn't been fed in 36 hours. Some people ask me, where this name Cali came from. I tried to write California on here, but I ran out of space on my tape, so I ended up with Cali. I created this starter about 3 or 4 months ago. I made a video about this where I wanted to create a California starter, so I ordered some flour from California from the Central Milling Company, and it came from Petaluma, California, which I later found out was just a shipping distribution center, and the flour could have come from anywhere, and the company is actually located in Utah. But I didn't want to rename my starter. I couldn't think of anything with Utah in the name other than Johnny Utah, which is kind of a stupid name unless you're Keanu Reeves. So this is still my starter Cali. So anyway, on day 1, I took this starter and I used this beaker. You'll see this in the video, so we could really measure the percent rise each day. So I decided to start with a 1-2-2 feeding ratio. That's what I normally use. So I started with 30 grams of starter, 60 grams of flour, 60 grams of water to give me a total of 150 grams of new starter each day. I mixed that together. I put it in this beaker. I put it in front of a camera with the clock, a thermometer, so we could really measure what was happening. And over the course of that 24-hour period, the starter only rose about 80%. It didn't even double, and it took 11 hours to get to its peak. That's really the definition of a weak starter. I mean, when you think about what makes a strong starter, you want your starter doubling in volume every 4 to 6 hours, depending on the temperature. My temperature was in the low 70s throughout this entire experiment. 73 Fahrenheit was probably the average. That's 22.8 degrees Celsius. So day 1 just proved that my starter was really quite weak. Then on the morning of day 2, I decided to feed my starter every day at 8 a.m. This is important for starter maintenance, is you want to be on a regular feeding schedule and you never want to go more than 24 hours without feeding. This is where I had fallen down on the job, prior. I was going 36 hours without feeding it. Some days I would skip a day and I'd go 48 hours. You really never want your starter to go more than 24 hours without it feeding. That's really the maximum. So on the morning of day 2, 8 a.m., the most important thing you do before feeding your starter is assess how much food did the starter eat the day prior. So I looked in the beaker, and what you see here is that even with that slow rise, 24 hours later, the starter still hadn't consumed all of its food. So you want to use this data point to determine whether you should change your starter feeding ratio. This is how you determine whether to change the starter feeding ratio, is you see, has the starter consumed all the food from the prior day? So because I did a 1-2-2 ratio, it didn't consume all the food. I stick with 1-2-2. There's no benefit to changing that. Some people will say, if your starter is weak, go up to 1-3-3, go up to 1-4-4. You can't force feed a weak starter. So this shows there was still food left. There's no reason to change the starter feeding ratio when you see that happen. So now let's talk about starter feeding ratios, because I know this can be confusing. The most common feeding ratios are 1-1-1, 1-2-2, 1-3-3. Those ratios are basically 3 numbers. The first number is your quantity of starter that you're carrying over from the prior day. The second number is the amount of flour as a ratio of the starter. The third number is the amount of water as a ratio to the starter. 1-1-1 is equal parts. We could have done 50 grams of starter, 50 grams of flour, 50 grams of water. In a 1-2-2, it's 30, 60, 60. You just do the math. So when you think about your starter feeding ratio, the easiest way to think about this is through something I call the camping analogy. So when we feed our starter, we're starting with our existing starter, we're adding flour, we're adding water. I think of this as if you're a camp counselor and you're sending some campers out for an overnight trip, and you have to figure out how much food and drink to send with them. So in a 1-1-1 feeding ratio, I send for each camper 1 meal and 1 bottle of water. In a 1-2-2 feeding ratio, for each camper, I send 2 meals and 2 bottles of water, etc. And then what I do to assess the sufficiency of that feeding ratio is the next morning, when the campers come back, if I send 30 campers out and 30 campers come back the next day and they still haven't eaten all the food that I gave them yesterday, I don't change the starter feeding ratio. If I send 30 campers out with 30 meals and 30 bottles of water and only 20 of them come back, then I know I'm starving my campers, so I need to increase my feeding ratio. So the next day, I'd probably go up to 1-2-2. If none of the campers starve to death, then you don't change the feeding ratio. So then the obvious question is, how do you know if your starter is starving? Here's what a starving starter looks like. Totally flat, no bubbles or these tiny pinpoint bubbles, completely liquefied, and this thin layer of alcohol forming on the top. That's the classic case of what a starving starter looks like right there. Now, some people will say, just overfeed your starter. Just go up to 133, 155. You can't force feed your starter. It's impossible. Starter eats flour and starches when food is available, and it doesn't eat it when it's not available. It can't eat faster. Starter is not hungry. Starter doesn't have a stomach. It doesn't have a brain. It doesn't have fat stores. It eats in the presence of food, and it starves when there's no food. So there's no benefit to overfeeding your starter. So resist the temptation, because you'll just waste a lot of flour. So on the morning of day 2, I assess how much food was left from the prior day. There was still clearly food in the beaker, so I don't change my starter feeding ratio. I feed it 122 again, and then what happens is the starter doubled in 8 hours, so now it's improving. It's increasing in speed and it's increasing in strength. So I'll show this chart with the results of each day so you can see the starter doubling time decreasing. That's what we want to see, is we want to see these blue bars going down each day. That's the time that it takes to double. So on the morning of day 3, it's 8 a.m. We always feed at the same time, but the first thing I always do before feeding is I assess, did my campers starve to death? How much food was left? So now I look in the beaker, and here you can see, unlike day 1, all the food was consumed. And when you see your starter really thin and watery and very few bubbles on top, that means that your starter is running out of its food source. I wouldn't say this is completely starving because you wouldn't see any bubbles on top, but this is definitely lacking food. So now on day 3, we do something very important, change the starter feeding ratio, because my starter is starving. So now that we go up to a 133 feeding ratio, we have to do some math here, because I still want the total quantity of the fed starter to remain 150 grams. So the way you do this is you take 150 grams divided by the number of parts of your feeding ratio. 1 plus 3 plus 3 is 7. 150 divided by 7 is 21.5. So I'm going to round up to 22 grams of starter, and then I'll use 64 grams of flour, 64 grams of water to keep our total at 150. But note here, and I'll come back to this, we're actually reducing the amount of starter that we're going forward with. We had 30 grams in our formula yesterday. We're going down to 22 grams today. That's going to be important. So I mix up the starter based on the new ratio. We watch what the starter does here. It's increasing in speed again. Now it's doubling in 7 hours versus 8 hours yesterday. But something else interesting is happening here, because we didn't just increase in speed from 8 hours to 7 hours, we also increased in strength in another way, because I went from 30 grams of starter yesterday as my base to 22 grams of starter today. So I not only increased my starter faster by doubling in volume, but I actually lifted more weight. It's almost like we went from one weightlifting class to another class. In the 1-2-2 ratio, I had 30 grams of starter trying to rise 120 grams of food, so that's 4 times its weight. In 1-3-3, I have 22 grams of starter trying to lift 128 grams of food, that's 6 times its weight. And it did it in 7 hours versus 8 hours. So it not only rose faster, it lifted more weight. So my starter really strengthened here more than it appears just in that change from 8 hours to 7 hours, because I'm using a smaller starter quantity to begin with. Day number 4, we assess our food source again. Now this looks similar to day 3, but this is still slightly thicker. It hasn't totally thinned out, and there are more bubbles on top here. This is kind of a judgment call. I'm going to keep this feeding ratio at 1-3-3, because this doesn't look like it's totally starving to me. doesn't smell like alcohol. It's not completely flat, and there's still bubbles on top, but this is close. There's just enough food here, but we're going to keep it at 133. So we watch our starter on day 4. Now it doubles in height in 6.5 hours. Again, an improvement from the prior day where it doubled in 7 hours. Now we're at 6.5, still making good progress. So it's the morning of day 5. We size up our starter. This again looks pretty flat. It looks like it's almost consuming all the food here. So today we're going to change something else. Instead of changing the feeding ratio, I can also change the feeding interval. So instead of feeding this 133 every 24 hours, I'm going to feed it 133 every 12 hours. So I'm just arbitrarily picking that point in time because I know it's going to be post-peak because we're peaking in roughly 6.5 hours. I'm going to cut this off at 12 hours and feed it again. And sometimes you can boost your yeast production by doing a shorter interval because there's a theory that when you feed your starter, the yeast population grows by about 25% as the starter is rising in the vessel. Right when it peaks at the top, the yeast will still grow another roughly 9%, according to some studies that I've seen, after it peaks. So we make sure that our yeast is at peak population up there. I'll pick that 12-hour interval. We'll refeed this and see if we can get a little bit more pickup here by trying to catch the yeast population at its peak rather than letting it decline in that extra 12 hours until you get to the next morning. So our day 5 morning rise at 133 actually took 6.75 hours. That's roughly equivalent with 6.5 hours from the prior day. So I'm not seeing any improvement here from the 133 feeding yesterday to the 133 feeding this morning. So now at 8 p.m., we do a 133 feeding at the 12-hour interval. So we size up our starter here. You can see there's plenty of food left. So this isn't a question of whether or not the starter is starving. I'm just arbitrarily deciding that I'm going to throw out a whole bunch of food here to try to catch the starter at a higher population before it declines. So we do a 133 feeding at 8 p.m., let this go overnight. So the second rise on day 5, 6.5 hours. So we're not seeing a big improvement here. Our last 3 readings were 6.5 hours, 6.75 hours, 6.5 hours. So we're seeming to hit a little bit of a plateau here. It's the morning of day 6. This is the last day of our sentence. We're going to size up our starter here this morning. You can see there's still plenty of food left from the 133 feeding that we did 12 hours ago. We're going to feed this 133 again. So this is our morning rise on day 6. This is our fastest ever, 5.5 hours to double in volume. This starter is still strengthening. So you'll notice that this improvement came after 2 back-to-back feedings at the 12-hour intervals. If we compare this 5.5-hour doubling time to where we were the morning of day 5, this is almost a 20% improvement, strictly attributable to the change in the feeding interval with no change to the feeding ratio. It's the middle of day 6. I think we're going to call this done. Our 6-day sentence is over. We have more than doubled the strength of this starter. Let's look at the chart. So here's the chart showing the number of hours that it took to double each day. If you recall, on day 1, we started at 11 hours, then we went to 8 hours, 7 hours, 6.5 hours. We kind of plateaued around that 6.5 range. We dropped down to 5.5 hours was our best case on the morning of day 6. So this shows how that doubling time declines as your starter strengthens. Another way to look at this is to look at the number of milliliters that we rose the starter divided by the number of hours that it took. I like this chart as well. So this red line shows the rise in milliliters per hour. So you want this chart to be going up. That's basically showing the speed of your starter. But what happened in this scenario is because we changed from a 122 feeding to a 133 feeding on day 3, you can't just look at the speed. You also have to look at what I call the strength factor because our starting quantity of starter went down on day 3. So that rise on day 3 was actually more than just increasing speed. It was increasing speed and the volume. So now we do another calculation where I take that milliliters per hour and now divide that by the number of grams of starter that we started with. And this is your true strength factor of your starter. The strength factor of your starter is the milliliters of rye divided by the number of hours that it took to double, divided by the number of grams of starter that you started with. This is a true power or strength factor of your starter. And you can see that we peaked on day 6 at 1.06. What that means is 1 gram of starter rose 1 milliliter of volume in 1 hour. That's a really interesting ratio, and I'll do some additional experiments on that, but I think that's a really good comparison to see when you hit really the optimal strength of a starter. So if you look at that strength factor on day 6 where we hit 1.06 compared to where we started with a strength factor of 0.3, that's a 250% increase. This starter improved its strength by 2.5 times. I mean, that is an unbelievable improvement. I'm blown away by this, that in this short of a period of time, I was able to completely transform this starter into like a super powered starter. And it's not just looking at the chart. The starter smells different. It feels different. It's frothy, it's bubbly, it's yeasty, it smells wonderful. I mean, this totally changed the nature of the starter. Because when you do these frequent feedings and you get a really strong starter like this and you keep it well fed, it also de-acidifies the starter. It takes the acid level down. So it favors the yeast and you get a much more yeasty, stronger starter when you do this. So what's the bottom line? No tricks, no gimmicks. I had a bag of flour, a bucket of water, and my existing starter, and I increased my starter strength by 2.5 times just by focusing on that feeding ratio and the feeding interval. That's the only tools I had available to me. It was an incredible result here. Now, some people will say, this seems like a lot of work. You know, I just used my weak, unfed starter. You can make bread with an unfed starter. It just takes a long time. And I don't want my bread to take forever because in episode 5, I was making bread at 2:30 in the morning. That's kind of a hassle. So by having a stronger starter, it helps you control your baking schedule. It helps you compress your baking time. And I have a feeling when we bake these loaves with the improved starter from this experiment, the loaves are actually going to look better and they might actually taste better. We'll see. So let me give a quick rundown of the experiment. This experiment is exactly the same one I did in episode 5. The only difference is that I'm using a different, presumably stronger version of my starter in this episode. So if you didn't see episode 5, I recommend to go back and watch the beginning of that video that talks about why we're doing the experiment, the setup for the experiment, and it goes through the recipe in detail because I'm replicating all of that exactly here today. The reason we're doing this experiment, just quickly, is because we're trying to create tools to help you manage your baking schedule. If you want to stretch out your bulk fermentation time from a standard recipe, what would happen if you reduced your leaven percentage from 20% to 10% or 20% to 5%? Similarly, if you're trying to speed up your baking schedule, what would happen if I take a recipe that calls for 20% leaven and I increase it to 30%? That's the whole reason for doing this experiment, is to try to come up with some analysis and some data and some rules of thumb to help you determine how you can speed up or slow down bulk fermentation. Now, as I said, the experiment, we're baking 4 loaves, 30% leaven, 20% leaven, 10% leaven, 5% leaven. All other factors are exactly the same. And then lastly, the recipe that I use is the tartine bread basic country loaf recipe. I follow this by the book. You can find that recipe on the internet, on the Tartine Bread Bakery website. I follow it exactly, so if you want to figure out the details of what I've done here, it's exactly as written in the recipe. I will briefly just put up on the screen the type of flour that I'm using in this recipe for your reference. Now let's take a look at the leaven before I mix it into the recipe so you can see what it looks like. Now for the leaven, I follow the tartine recipe that calls for an overnight leaven build, at a cool kitchen temperature. So what I do is it's essentially a 1-10-10 feeding of your starter. So I took 10 grams of starter, 100 grams of flour, and 100 grams of water. I mixed that together using 78-degree water, which is 25.6 degrees Celsius as called for in the recipe. So it gives it a little bit of a jump start to get going, but then it sits in your kitchen overnight, and my kitchen in the winter gets down to about 62 degrees Fahrenheit, which is roughly 17 degrees Celsius. So this is a slow, cool build overnight. So this has been going exactly 12 hours, which feels like a long time, but it's not at that temperature and with that 1-10-10 feeding. So here, let's take a look at the leaven. Look how airy that is. I mean, that is unbelievably aerated. Let me hold it up to the camera here. The leaven is also domed on top, which you want to look for. That means that it hasn't totally peaked yet. That leaven looks super aerated and very strong compared to the leaven that I used in episode 5. So the next thing I'll do is the float test. This is controversial. Some people say the float test is unreliable. I have, somewhat mixed results with it, but the tartine recipe calls for the float test. It gives you the formula to use in the leaven. So if you actually follow the recipe, the float test actually works, and it's usually a pretty good indicator. Some people say the float test doesn't work because they use a different starter recipe, different hydration. There are a lot of ways to make the float test not work, but if you actually follow the recipe, it works. Or it should. We'll see. So the way that I do this is I just take a spoonful off of the top. You can see what I'm taking there. Carefully flop that into the water because you don't want to degas it on the way in. And that's really floating. That is very aerated and floating in the cup. So I would call that a pass on the float test. That looks really good. Now I'm going to mix the ingredients off camera. I'll do 4 stretch and folds, and we'll pick this up in 2.5 hours. So it's been 2.5 hours since I mixed the dough. Let me bring you up to speed on where we are in the process. So I follow the recipe from the Tartine Basic Country Loaf as our standard recipe with 20% leaven. Then I adjusted the recipe for 30%, 10%, and 5%. Now when I do that adjustment, I'll put this chart up on the screen because you have to make small adjustments to the flour and water in each one of these loaves to ensure that the loaves come out the exact same total weight, they come out with the exact same total hydration percentage, the exact same percentage of salt, and the exact same ratio of flour and water. Because the starter is basically 100% hydration, the higher ratio of starter versus the lower ratio of starter can impact the hydration if you just follow the standard recipe. So you have to make small adjustments off of that standard to keep the hydration rates the same and to get the loaves to come out exactly the same weight. I meticulously measured everything, and these 4 loaves looked identical when I mixed them up in terms of weight, hydration, etc. So where are we now? I just completed the 4th stretch and fold. We're 2.5 hours into bulk fermentation. That's still a little bit early in the process to be doing the bulkomatic assessment because the dough hasn't really moved much and it hasn't really settled down into the bowls after the 4th stretch and fold. So I'm going to let these sit for another, let's say 30 to 60 minutes, and I'll come back either at the 3-hour mark or the 3.5-hour mark, and we'll do the full assessment of the criteria to see where we are as our starting point for determining when bulk fermentation is done. It has been 3.5 hours since I mixed the dough. Let's take a look at where we are. Now I'm going to go through all 9 criteria on the bulkomatic system. If you haven't seen the use of the system yet, I recommend watching episode 3 where I go through all these criteria in detail. I'm going to do this pretty quickly here. So the first thing that we always do is check the temperature. Now this recipe calls for a recommended fermentation temperature between 78 and 82 degrees Fahrenheit. That's 25.5 to 28 degrees Celsius. I try to be right in the middle of that range of 80 degrees Fahrenheit or 26.7 degrees Celsius. These are falling right in that range, 80 degrees, 80 degrees, 80 degrees, 81 degrees Fahrenheit. So we're right in the middle of the temperature range where we want to be. Now I took the temperature from when I first mixed the dough. So you have to look at the temperature over the whole lifetime of bulk fermentation here. When I mixed the dough, this was at 81 degrees Fahrenheit or 27 degrees Celsius. It dropped down to 78 degrees Fahrenheit when I mixed the salt. Typically that'll happen because when you mix the dough, you're introducing room temperature air. So I was down to say 25.6 degrees Celsius after adding the salt. Then it crept back up 78 degrees, 79 degrees. Now we're sitting at 80 degrees, which is where we want to be. I use my oven with the light on as a proofing chamber. Keeps this dough temperature really in that nice range of about 80 degrees Fahrenheit, 26.7 degrees Celsius. So we're in a good place from a temperature perspective. Maybe started a little bit lower, but we're at the point where we want to be right now. So I'd say we're a little bit left of center in terms of the Bulkomatic Goldilocks range where we want all these criteria to be. The recommended time in the recipe, the minimum time they recommend is 3.5 hours after adding the leaven. We're sitting at 3.5 hours right now, and we're looking for a 30% rise. This is moving a little bit, but this dough is not ready yet. I've never hit that 3.5 hour mark, even with the super strongest starter I've ever used in my life. I don't know who hits that 3.5 hour mark. I never have. The percent rise, as I said, we're looking for a 30% rise with this recipe. The recipe guidance calls for 20 to 30%. I tend to go with 30% and have better results with that in this recipe. Now this dough is still domed up on top because of the last stretch and fold, so it's actually a little tricky to read the percent rise. I have milliliter markers here on my side of the bowl, but this is definitely up from where it started. It's just domed up in the middle. I'm going to let that settle down for another half hour or so till I make a call on that, but it's above the starting line. Let me put it that way. Is the dough domed on top? Absolutely. This has a nice dome on top. That means there's air pushing up from the bottom. Are there bubbles on top? We usually look for air bubbles pushing their way up to the surface. I see them kind of starting. I see some bulges starting under the tops of the loaves there, but no real bubbles on top yet. Are there bubbles on the sides? Absolutely. I mean, this is vigorous bubbling on the side of these bowls. I mean, here's number one. A lot of bubbles on the side. I also look for the size of the bubbles, and there's a mix of kind of small, medium, and large bubbles. That's a great sign that we're off to a strong start with fermentation. I did not see this in the prior experiment. I did not see those bubbles on the side at this point in that process. So this implies that we are off to a really good start here with the bubbles on the side. Then we do what I call the wobble test. We shake the bowl. Now this dough has some movement much further along than where it was in the prior episode. When the dough moves like that, or what I call splashes against the side of the bowl, that means that the dough is aerating. So this dough is moving in number one. I'd say that that's starting to get loose and aerated. Loaf number two, our 20% loaf, that's somewhat loose and aerated, a little bit less than number one as we would expect. Number three, still a little bit stiffer, but I'm seeing a little bit of movement there. And number four, this is our 5% leaven, you know, the least movement there. So this one really follows the continuum. When you shake that bowl, there's more air in the 30% loaf than there is in the 5% loaf, and it follows pretty much a continuum across the board. The next thing I do is I do a window pane test. Now the window pane test is really to determine, have we developed sufficient gluten during the stretch and fold process? So I did 4 stretch and folds on these, which is usually enough for this size of dough. Let's pull a window pane here and see how our gluten development looks. This dough feels nice and supple. It still feels pretty strong. I'm pulling on this pretty hard. That's a spectacular window pane right there. I can see daylight through that, just tearing at the edges. Really, really nice window pane on loaf number one. Let's take a look at loaf number two. These should all be pretty similar, but I like to get my hands on all 4 of the loaves here. Beautiful. Look at that. Beautiful window pane on loaf number two. And this is with whole wheat in this loaf. 10% whole wheat using the baker's percentages, which tends to tear the window pane. There's no tearing at all there. That's spectacular. Loaf number three. Really nice supple feel. Look at that window pane. Gorgeous. Really translucent membrane. I can see my fingers through that. It's like a translucent skin on loaf number three. Loaf number 4. Same, just superb window pane on all 4 of these loaves. Fabulous. So our window pane is strong and translucent. We have sufficient gluten development in all 4 of these loaves. That means we don't need to do any more stretching and folding. Now, I still do the window pane as we go periodically through the bulkomatic test, because what happens is when you try to pull the window pane later in bulk fermentation, you'll actually feel the dough breaking down in your hands when it starts to get towards overproofing. So I continue to do that window pane as an early indication as to whether or not we're at risk of overproofing. And then the last test that I do is called the smell test. Now there's a continuum of smell here that I look for. On the underproofed side, your dough smells like flour and water. You know that smell when you initially mix your dough, you're smelling the flour mostly. On the other end of the spectrum, it smells like your starter. If you way overproof a loaf, it smells acidic. It smells, essentially with that starter smell. In the middle, what we're looking for is a transition where you go from that floury smell at first to something I call a ripe smell. And this is where you'll just start to lose the flour smell, the raw flour, and you'll smell something that smells like ripe fruit. It's a very subtle smell, but that's what I call ripe, and that's when you're really starting to get into the heart of bulk fermentation. And then as the dough reaches the end of bulk fermentation, in my experience, it develops a sweet smell. It goes from ripe to sweet, and I've said this before, when I smell the dough, I'm smelling it with my nose, but you can almost taste the sweetness on the tip of your tongue. So let me smell these. This is somewhere between ripe and sweet. Yes, that is on the verge of turning the corner into the sweetness, and I also see one bubble on top of that loaf. So we're getting a little bit of bubbling on top. This one smells ripe, the 20% loaf number 2. That would make sense. Not quite as far along as loaf number 1 because we started with less leaven. This doesn't smell like raw flour, but it does not smell sweet. Number 3. That smells pretty much like flour. Number 4 smells like a bag of flour. So the smell test, absolutely you can smell, or I know you can't smell, but I can smell the continuum here of almost sweet, ripe, still floury, totally floury. So that's the 4 loaves when we look at the test. Let me put all these indicators up here on the chart for loaves 1, 2, 3, and 4. I know there's a lot of data on the chart here, but you can still see that we're left of center from where we want to be. We want the vast majority of those criteria to be in that Goldilocks range to determine when we're done. We're getting there. We're really just at the early stages of bulk fermentation, but loaf number 1 is definitely moving along, and it's moving faster than what I saw in the prior test, which gives me some indication that the stronger starter is working. I'm going to track these now. Every 30 minutes, I'll check in. If there's not a lot to report, I'll come back in 60 minutes. And then as these get closer to finishing, we'll cut each one of these off and we'll do the complete test on each of the 4 loaves. So we're at 4.5 hours since we mixed the dough. Let's take a look at loaf number 1, which looks like it might be getting close. Now, I'm going to go through the full criteria here on loaf number 1, all 9 tests on the bulkomatic tool to see where we stand. So first, we take the temperature. 80 degrees Fahrenheit, that's right in the center of the range where we want to be. So this dough has been at the perfect proofing temperature since we started. The time has been 4.5 hours since we started. Now the tartine recipe recommends that 3.5 to 4.5 hour timing, but that also assumes a 20% leaven loaf in the standard recipe. So when we are sitting at 30% leaven, you would expect this to go a little bit faster than normal. So off of my typical benchmark of a 5.5 hour rise on the 20% loaf, a 4.5 hour rise on a 30% loaf seems reasonable. But I'm trying not to use time as an indicator here. I'm trying to use the other 8 variables and really let those variables tell us how much time we needed. The percent rise, it's a little tough to call because it's so domed up on the top, but I'm going to call this I'm going to call that a 30% rise. I think it's there. The way that I look at this when it's domed on the top is you have to look at where it is on the edge, which is at about 10%, and where it is in the middle, which is about 40%. And I kind of split the difference and eyeball that a little bit, but it looks like it's sitting, most of the mass is sitting at about a 30% rise. Is it domed on top? Absolutely. You can see that big shoulder around the edge is very airy. Are there bubbles on the top? I see one big bubble here, 2, 3, 4 bubbles on top. So we are seeing the aeration push up through the top of the dough, which is an indication that it's done. Are there bubbles on the sides? Absolutely. Still seeing that vigorous bubbling that we saw all along on the sides. Not a big change there, but I'd call that many bubbles. The wobble test. This is really important at this point because this is what gives me an idea of how aerated the dough is. That is splashing against the sides. See that shoulder splashing against the sides? That dough is pretty aerated, pretty far along. The window pane test, we're really just testing this to get our hands on the dough and make sure that we're not overproofing now. So I give that a stretch. It's tearing a little bit sooner, but I'm still getting a pretty good window pane there, but that dough is weakening, I'd say weakening a little bit with the tearing that I'm seeing there. So we don't want to let this go too much longer because we're starting to see some gluten breakdown. And then the smell test, absolutely that sweet smell. So this is right where I would call this in the middle of the range with that sweet smell, not acidic at all. This is really close. Maybe it needs a little bit more time, but I'm going to call it here at 4.5 hours. We're going to see how this loaf looks. Here's the bulkomatic chart for loaf number 1. You can see all of the variables are in that desired range. I'm going to get this into a shaping basket. Now, as we did in the prior video, we don't do pre-shaping or final shaping with these loaves. I'm just going to take this out of the bowl. I flop it into a shaping basket. We still let it sit on the counter for 30 more minutes because that's what the recipe would have called for between the pre-shaping and final shaping. So the dough is still fermenting. That's part of the reason that this recipe cuts off the percent rise at 20 to 30% because you have to accommodate for the dough continuing to rise during that bench rest at a fairly warm temperature of 80 degrees Fahrenheit or 27 degrees Celsius. So we want to comply with the recipe and let it sit for that 30 minutes. Then it will go into the refrigerator for an overnight cold retard and we'll bake it up in the morning. So now I carefully want to take this dough out of this bowl and get it into the shaping basket. As I put my hands on the dough, this feels really nice. Feels very similar to the loaves in the last episode at a fraction of the time. This loaf took 6.5 hours in the prior video. And then I look at how that dough kind of droops down. This is further along than it was in the prior video. When I see that dough drooping like that, this is definitely done. We flop it into the shaping basket. I don't do any shaping of this. I just let gravity kind of do the shaping here. This is how Sir Isaac Newton would have shaped his loaves. Let gravity do the work. And then I like to shake. Yeah, that's loose and aerated. That's a beautifully proofed loaf right there. I think that one's in really good shape at the 4.5 hour mark. So this is substantially quicker than we saw in the prior episode, which I can only attribute to our stronger starter. Let's see how the other 4 loaves shape up. 30-minute bench rest, into the fridge for overnight cold retard, bake it in the morning. We are 5 hours into bulk fermentation. I believe loaf number 2 may be done. This is right on the heels of loaf number 1. So this is our 20% leaven loaf by the book from the tartine recipe. Normally this would take 5.5 hours. In the past, this is sitting at 5 hours. I guess that makes sense, assuming that this starter and leaven is stronger than I've ever had before, which is possible. Let's go through the tests. Number 1, temperature. 80 degrees Fahrenheit, right in the middle of the range. That's 26.7 degrees Celsius. That just indicates that the recommended timing is probably correct because the recommended temperature is correct. Recommended timing per the recipe, 3.5 to 4.5 hours. We're sitting at 5 hours, which I said is typical for me with these loaves, typically closer to 5.5. Percent rise, This is sitting right at 30%. That's right where we want it to be. Is it domed on top? It is. There's a nice shoulder around all the edges there. Are there bubbles on the top? Not many. 1, 2, 3 small bubbles, I would say. So I'm not seeing as much bubble activity on the top. Are there bubbles on the side? Yes, I would say many. Very similar to loaf number 1. A lot of aeration visible in that loaf. The wobble test, that's moving almost identically to loaf number 1. See that splashing of the shoulder against the side of the bowl? That is a loose aerated loaf. The window pane test, this just tests how far along we are in terms of gluten development. Do we have anything to worry about in terms of overproofing? This feels a little stronger to me than loaf number 1. And it's not tearing quite as quickly. Yeah, that's still a really nice, really solid window pane there on loaf number 2, just tearing at the very end. So I'd say that looks like it's in good shape. It's still a relatively strong and translucent window pane with some weakening towards the end there. And then the smell test. It's not quite as sweet as loaf number 1. It's definitely past the ripe stage into the sweet stage. Just slightly to the left of center compared to loaf number 1. So based on the smell test, this loaf is slightly left of where loaf number 1 is in terms of its proofing here in bulk fermentation, but I still think this is done. We may be talking minutes of differences between these. Let's get this out of the bowl. I like to get my hands on the dough here and feel this. This feels, I'd say, very similar to loaf number 1. Maybe when I first touched it, it felt slightly stiffer. Scoop it out. Our droop test, very similar to loaf number 1. Maybe not quite as far along. I think that's in a good place. Flop it into the pan. Let gravity do the work to shape that up for us. Shake it. That is slightly stiffer than loaf number 1, but that's a nicely proofed loaf right there. We're going to give this a 30-minute bench rest, get it into the refrigerator overnight, bake it up tomorrow morning. It has been 6.5 hours since we mixed the dough. I think loaf number 3 may be done. Let's do the test. Dough temperature, 82 degrees Fahrenheit. So now we're pushing the high end of the range. We don't want it to go any warmer than that. Our time is sitting at 6.5 hours. We don't really have guidance on time for a 10% leaven loaf, which is what this is. This has taken about an hour longer than the 20% leaven loaf. That's pretty quick on the heels of the 20% loaf, in my opinion. Is this domed on top? It is domed on top, not quite as high as we saw in loaves number 1 and 2. Are there bubbles on the top? A few small ones. 1, 2, 3, 4. 4 smallish bubbles. I'm not seeing the big airy bubbles. Are there bubbles on the side? I've really seen this since the start. Really nice bubbling on the side of these bowls. There's a lot of fermentation activity happening in there. The wobble test, that looks pretty good. That looks very similar to loaf number 2. There's a lot of air in this loaf. It's just not as puffed up on the top. I don't see that big shoulder around the edge like I saw, but in terms of that splashing of the dough along the edge, I think that's there. The window pane test, like to get our hands on the dough to see what's happening here. And that is still a really nice, strong window pane. Wow, that is surprising. Just tore there at the end. But this late into bulk fermentation, 6.5 hours, that's an impressive window pane. So this isn't really pushing overproofing, in my opinion. And then the smell test, that nice sweet smell. Maybe slightly to the left of loaf number 1, closer to what I smelled in loaf number 2. So I think this is done. Here's the chart for loaf number 3. Let's take a look. Our temperature just started to creep up at the end. If I look at the average temperature over the duration, it's probably now slightly to the right of the midpoint. The time we're sitting at is 6.5 hours. Because this chart is calibrated for the 20% loaf, the time calibration is not really appropriate here. We're using this test to determine what these times should be. The percent rise was right at 30%. It was domed on top, but not quite as much as the other loaves. There were a few bubbles on top, but not many of the big bubbles. There were a lot of bubbles on the side, which we saw through the whole duration. The wobble test is loose and aerated, similar to loaf number 2, maybe slightly less. The window pane strong and translucent, surprisingly, this far into bulk fermentation. And the smell test, very sweet. Let's get this into a shaping basket. I like to get my hands on the dough. It feels super soft and supple, nice and airy dough. Now, if this dough had been overproofing, which this isn't even close, I would start to see all those gluten strands around the edges, and this would be very sticky as I try to pull it out. This feels nice because it's a real cohesive ball of dough. And when I lift it out, it's a little droopier than loaf number 2 and loaf number 1. Some of that just comes with time. The longer these loaves ferment, they do start to break down a little bit, but I didn't see it much in the window pane, but that loaf's a little soft. Shake, beautiful shake. Really nice movement. Looks very similar to loaf number 1, actually. That's a nicely proofed loaf. I think that we got that right at the right moment. I'm going to cover this, give it a 30-minute bench rest, then we'll bake it up tomorrow. It has been 8.5 hours since we mixed the dough. I think loaf 4 may be done. Let's do the test. Temperature, 80 degrees, right in the middle of the range. All these loaves have been right in the range where we wanted them, 80 degrees Fahrenheit, 26.7 Celsius. The time is 8.5 hours. Obviously, we can't use the guidance for the time because that's based on 20% leaven. This is our 5% leaven loaf. Now, interestingly, when I made this loaf in episode 5, it took 15 hours, and here we're at 8.5 hours. So we've almost cut our bulk fermentation time almost in half with the stronger starter and stronger leaven. The percent rise is right at 30%. That's a nice rise on that loaf. Is it domed on top? Very similar to loaf number 3. Not quite as tall as 1 and 2, but it has a nice shoulder around the edges there. Are there bubbles on the top? There are 1, 2, 3, 4 bubbles on top. Are there bubbles on the side? Yes, still vigorously bubbling on the side. All these loaves have looked really good on the side. The wobble test, loose and aerated, very similar to loaf number 3, I would say. Almost identical. Let's do a window pane to see how our gluten feels after 8.5 hours. Sometimes you'll get some gluten deterioration. That feels fantastic. Look at that window pane, 8.5 hours, just tearing a little bit. That's still an amazing window pane for 8.5 hours of bulk fermentation. This dough looks really good. The smell test, that smells sweet right down the middle like the other ones. I think loaf 4 is done. So here's the bulkomatic chart for loaf number 4. Let's get this out of the bowl into a shaping basket. Now this is where I like to feel the dough. This feels very cohesive, definitely not overproofed. It feels a little stiffer than loaf number 3 to me. Let's see how it feels when it comes out. That looks pretty similar to loaf number 3 based on the way that's drooping in my hand. It feels slightly stiffer to me. So I hope that one is not under. Let's shake it. That's a good shake, but yeah, this loaf feels slightly stiff to me. Maybe that could have gone an extra 30 minutes. We'll see how that bakes up tomorrow. I'm going to give that its 30-minute bench rest, then it'll go into the fridge for the overnight cold retard. We'll bake it up in the morning. Here's a summary of the bulk fermentation times for the 4 loaves. It's the morning of day 2. It's time to score and bake the loaves. I'm preheating the ovens now. So if you recall yesterday, as we finished up bulk fermentation on each one of those loaves, I flopped it into a shaping basket. We gave it a 30-minute bench rest. Then it went into the refrigerator. Loaf number 1 is coming out of the refrigerator about 14 hours after it went in. The successive loaves went into the refrigerator later, so I'll be taking each one of those out later to keep that final proof cold retard time consistent at 14 hours for each one of these loaves. I'll be baking them over the course of the day today. I'm going to score and bake these loaves off camera. There's not a lot to see there. Let me just give you a quick summary of what I'm going to do. I basically take the loaves out of the shaping basket, flop them on the parchment paper. We don't do any pre-shaping or any final shaping. We want to see that bulk fermented dough without introducing any irregularities from shaping into it, just like we can put an X-ray camera on these loaves coming out of bulk fermentation to see what the crumb looks like. And ideally, when we bake and cut open all these loaves, they should look exactly the same, even though the bulk fermentation times were wildly different, because we're trying to prove that by controlling the bulk fermentation time and the leaven percentage, you can get the exact same proofing on different loaves over a different period of time. So I'll take each one of these loaves, I'll score it. I just do 1 slash down each one of the loaves, put it into a preheated Dutch oven. So I'm preheating my oven at 500 degrees Fahrenheit, that's 260 degrees Celsius with the Dutch oven in the oven. I put the loaves into the Dutch oven with the lid on, reduce the heat to 450 degrees Fahrenheit, that's 232 degrees Celsius. Bake them for 20 minutes with the lid on. Then I remove the lid for the last roughly 15 minutes and watch them for doneness. These loaves typically bake up in about 35 minutes total. After the loaves have baked and cooled, we'll cut the loaves open and evaluate the crumb. And if this experiment worked, all 4 of these loaves should look exactly the same. So the 4 loaves are baked and they have cooled. Let's look at what we have here. So starting on my left, loaf number 1, 30% leaven, 4.5 hours bulk fermentation. Number 2, 20% leaven, 5 hours bulk fermentation. Number 3, 10% leaven, 6.5 hours bulk fermentation. Number 4, 5% leaven, 8.5 hours bulk fermentation. The idea behind this experiment is that you can modify your leaven percentage to speed up or slow down your bulk fermentation. And if you use the indicators to determine when bulk fermentation is done, you can end up with 4 identical loaves. These loaves are as identical as any 4 loaves I've ever baked. I do these experiments all the time, especially with these difference in bulk fermentation times. I'm kind of dumbfounded at how similar these look. This was the idea behind the experiment, but I didn't even expect it to look this close. So let's just take a look at some of these loaves. The first thing I have to mention, loaf number 1, for example, I say this in every video, I'm going to say it again. This is a loaf with no pre-shaping and no final shaping. This is bulk fermented dough. I flopped it into a loaf pan, put it in the refrigerator for 14 hours, and I baked it with no shaping. Bulk fermentation makes the bread. Pre-shaping is overrated, final shaping is overrated. If you bulk ferment your dough properly, it makes the loaf. I mean, look at this, loaf number 2, perfect shape, perfect symmetry, without shaping. Loaf number 3, loaf number 4, look at this. 8.5 hours of bulk fermentation. I mean, that's a long time. That loaf looks as fresh and round as loaf number 1. I mean, that is just extraordinary. Now, this is a significant difference from what I saw in the prior experiment with the weak leaven. What I saw in that experiment was the longer the loaves fermented, they just flattened out. Number 1, you could see them getting wider and flatter. And number 2, the height of the loaves, you could almost have drawn a line that showed which loaves were bulk fermented the shortest time to the longest time, because there was a very steep downhill decline in height. Look at these 4 loaves. I mean, those are almost identical in height. Loaf number 3 is just a hair shorter in height than 1, 2, and 4. Loaf number 4 is the same as loaf number 1. It's extraordinary. I've never seen anything like that. Now, the reason this is different is because in the prior experiment with the weak leaven, I've said this before, in your starter, you have yeast, which is trying to rise the loaf, and you have lactic acid bacteria and protease enzyme that essentially is trying to destroy the loaf. The more acidic, the more acid that builds up from the lactic acid bacteria starts to slow down the yeast fermentation. And the acidity also releases something called the protease enzyme, which eats the gluten. So when you have long fermentation times, it gives lactic acid bacteria time to build up that acid load, release the protease enzyme, and slow down the yeast. And you get in this constant battle where the lactic acid bacteria starts to outrun the yeast in long fermentations. What happens here is by having a strong leaven, it favors the yeast. It lets the yeast get off to a stronger start so that it doesn't get outrun by the lactic acid bacteria. That is absolutely evident here. When I compare loaf number 1 to loaf number 4, that's 4 hours difference of bulk fermentation time. There's no evidence of gluten deterioration in that loaf. It's just extraordinary. But the real test of bulk fermentation is to look at the crumb. So let's cut these 4 loaves open and see what the crumb looks like. Now the idea behind this again was that if we use a tool like the bulkomatic indicator, and we can cut off bulk fermentation at exactly the same point, regardless of the bulk fermentation time. So we totally ignored the clock, we looked at the physical attributes of the loaves, and I tried to cut these off at identical points in time. If I did that, these loaves should look exactly the same when we cut them open. The crumb should look identical. Loaf number 1, 30% leaven, 4.5 hours bulk fermentation. That is a spectacularly proofed loaf of bread right there. Got that one big cavern on the side. Can't make a judgment call about that one. The rest of the loaf looks perfectly proofed. That's a beautiful loaf. The height is amazing, and that crumb is gorgeous. So I'd say that's a really nicely proofed loaf, number 1. I don't have much more to say about that. Loaf number 2. Another beautifully proofed loaf, number 2. And similarly, one little cavern there, just like on loaf number 1, but that looks almost identical. Right here is the essence of the experiment. Compare loaf number 1 to loaf number 2. Those are almost identical loaves. I couldn't tell them apart if I set these down and got them mixed up. One had 4.5 hours of bulk fermentation on my left, 5 hours on my right, 30% leaven on my left, 20% leaven on my right. Those two came out identical for all intents and purposes. Loaf number 3. Now this loaf feels a little more compact to me. It just didn't quite open up the way the other ones did. Let's see what the crumb looks like. Wow. I gotta say 3 for 3. Another beautifully proofed loaf of bread on number 3. That's incredible. Again, compared to loaf number 1, almost identical crumb structure. Loaf number 2, almost the same as loaf number 2. These are incredible. And just the height of these loaves is amazing. I can really tell the difference of having a stronger leaven. The loaves are just taller, much better aeration in the crumb. Loaf number 4, 5% leaven, 8.5 hours bulk fermentation. Okay, this one is interesting. I don't know what to say here. Have that one giant hole there in the middle. The rest of the crumb actually looks very similar to the others, but I got one giant air gap there. Sometimes when you see a big air gap like that, it could be caused by underproofing. This clearly is not due to underproofing. This is really a well-proofed loaf. This just got some air in it somewhere. It's hard to believe, but this actually can happen. This was on a different shelf in my refrigerator. And I've said this before, and I tell people this, that your temperature can vary in your refrigerator. I only had room on my bottom shelf for those 3 loaves, and I put this loaf on a higher shelf in the refrigerator, and I believe what happened here is for that first few hours in the refrigerator, this loaf actually fermented a little bit more than those did, and it opened up after it was in the shaping basket. I think that's what caused that large hole there. But in terms of the proofing, when I look at the rest of the loaf, identical to the others. That's incredible. But in my experience, the bisection doesn't always tell the whole story, so I'm going to cut into these loaves a little bit deeper and see if we can do a better comparison of the crumb. So now I have sliced all 4 loaves. I've taken 4 slices off of each loaf in each one of the columns here. Loaf number 1, loaf number 2, loaf number 3, loaf number 4. If we take a look at these now, loaves number 1 and 2 are almost identical. This is our 30% leaven and 20% leaven loaves. Those slices could be interchangeable. Loaf number 3 didn't quite open up as much. You see, I don't see any of those big open holes in the crumb here. So loaf number 3, maybe we cut that off a hair earlier than loaves number 1 or loaf number 2. Just didn't quite open up. And then loaf number 4 doesn't look as bad as the bisection. I left the first cut off that had that giant hole in it. The other slices look very comparable to these other loaves, clearly. But similar to loaf number 3, I'm seeing a little bit more density of the crumb here and just a little bit more irregularity in the way that opened up, and I believe it was probably a few degrees temperature difference in the refrigerator for 14 hours. It can actually do that. But these loaves are so similar from what I'd call a proofing continuum. When you think of what does an underproof loaf look like, what does an overproofed loaf look like, these are in such a narrow band of proofing, it's really unbelievable. If I mixed all these up and had to sort them back out again and try to get them back into the original loaves, I would have an incredibly hard time doing that. So that really proves the essence of what we wanted to do in this experiment, that you can modify the leaven percentage to stretch out your bulk fermentation time or accelerate your bulk fermentation time. And if you use a good tool or have a good eye for cutting off bulk fermentation, you can have the proofing and the shape of the loaves come out nearly identically. This is really an amazing result of the experiment. Now, when we compare the slices here to the prior experiment, it's also interesting because these loaves are much more consistent across the board. Loaf 4 was really a standout in the prior experiment because it had really deteriorated. But these loaves, because the leaven is stronger, they also finish up in a tighter window. The difference between loaf number 1 and loaf number 4 is 4 hours difference. In the prior example, with the weak leaven, the difference between loaf number 1 and loaf number 4 was 9.5 hours difference. A lot of bad things can happen in 9.5 hours. So just the fact that these are fermenting faster, you're getting less variability between the high leaven percentage and the low leaven percentage just because of the clock factor, just because of the time. Because the thing that loves time is lactic acid bacteria. The more time it has, the more it works. It never slows down, and that's where you start to get the gluten deterioration with long fermentation times. Now, I also did a taste test, and I employed the services of a completely independent judge, my wife. We tasted all 4 loaves. These were interesting, especially compared to the prior experiment. These are incredibly mild tasting loaves, and there's very little difference in flavor between loaf number 1 and loaf number 4. That's a little bit of a surprise because some people think that you can increase the sourness of a loaf by really loading it up with more leaven, but it is not evident at all. In fact, if anything, loaves 1 and 2 were slightly milder than loaves 3 and 4. But across the board, all 4 of these loaves are relatively mild. When I compare this to the prior experiment with the weak leaven, loaves 1 and 2 were more sour than anything I'm tasting here, and loaves 3 and 4 were more sour than loaves 1 and 2 of that batch. So the 3 and 4 loaves of the weak leaven, super sour. The reason is because of time. That tanginess that you get in a sour flavored sourdough loaf, it comes with long fermentation times. So even though these times were longer relative to each other, 4 hours versus 8.5 hours, they weren't very long compared to the prior experiment, which went from 6.5 hours to 16 hours. So that long fermentation time is what builds the flavor, not the initial load of the leaven. The other thing to keep in mind here is because of the way that I was feeding this leaven over the last 6 days and refreshing every day, this leaven has an incredibly low acidity level compared to a typical leaven that you might not feed as frequently as what I did here. So because of that low acid load going into these loaves, it delivers an incredibly mild loaf. This is what Chad Robertson calls kind of a light French country style loaf, not the classic San Francisco sourdough flavor. This is the other end of the spectrum, and that comes from what he calls a young leaven or a really fresh, light leaven that's low in acidity, which is exactly what I created through my 6-day strengthening process. So now let's look at some charts so you can use the results from this experiment to help with your baking schedule and planning in the future. So the first one is just a simple summary of the hours that we saw for bulk fermentation time across these 4 loaves. You can see here loaf number 1 at 4.5 hours on the low end, 30% leaven, up to loaf number 4 at 8.5 hours or 5% leaven. So now let's compare these results to episode number 5, where we used our weak leaven. Now this is fascinating. You can see the blue bars were the bulk fermentation times for episode 5, where our leaven was weak. The red bars are from this experiment with where our leaven is strong. Massive difference in the bulk fermentation times. I mean, that is just an extraordinary difference purely based on the strength of the starter. Every other variable in this formula was exactly the same flour, same bulk fermentation temperature, the exact same process, the same person following the same steps. That would be me. And the times are dramatically different because of one thing, the strength of our starter. You can see that in every case, the strong leaven bulk fermented faster than the weak leaven, but that difference is extreme. I mean, it's extraordinary. The average difference between the weak leaven and the strong leaven in terms of bulk fermentation time is it takes 66% longer, 66% more time with a weak leaven to complete bulk fermentation than it does with the strong leaven. That's extraordinary, especially when you think about how much time you have to spend in the kitchen. Now at the lowest end of the range on loaf number 1, the difference was 44% longer. And at the other extreme end on loaf number 4, it took 88% longer, 88% more time to bulk ferment with a weak leaven than it did with a strong leaven. Now, using the results of today's experiment, let's put these on both the X and the Y axis so you can see what I call the fermentation curve. This shows the leaven percentage on the vertical axis and the bulk fermentation time in hours on the horizontal axis. And this looks like a curve that you see in nature. It looks like a curve that you see in fermentation. So this is what I believe to be a very reliable fermentation curve for this specific recipe. Interestingly, now if we look at the curve from episode number 5 with our weak leaven, it actually looks pretty similar. The times were much longer, but the shape of the curve is actually quite interestingly similar. Now, when you transition between these two, you can really see that the shape of the curves almost line up on top of each other, even though the total hours were significantly different. This is what happens when you have biological processes. They don't care about our clocks, they don't care about our time, and the reason these two curves look the same is because of what people call the laws of nature. So now just to wrap up our summary, in episode 5, I gave 4 rules of thumb for estimating how much your bulk fermentation time would increase or decrease based on changes in your leaven percentage. Those are shown in this chart. And what I've done is added in that column on the right the results from today's experiment. So now you can compare the numbers, just reading across the top row. If you tried to decrease your leaven percentage in order to extend your bulk fermentation time, this would be if you were trying to do an overnight bulk fermentation, for example, reducing from 30% to 15% would have caused a 50% increase in bulk fermentation time according to our weak leaven in episode 5. Based on today's experiment, it's showing a 39% increase in bulk fermentation time. So I'd say directionally similar numbers, but not exactly the same. If you read down through the chart, you can see that they all follow the same pattern. Today's results are directionally similar to what we saw in episode 5, but they're not exactly the same. All we can do is continue to do more tests. So what did we learn in this experiment? I would say a lot. So let me just recap some of the things that we found here. Number 1, the first rule of sourdough, you don't make the bread, the starter makes the bread. I kind of joked about that early in this video. Your starter can have a profound influence on the outcome of your loaves, much more than I ever imagined in my life. I really can't believe the difference in what I saw in the bulk fermentation, the shape of these loaves, the aeration, the flavor. So many factors changed with these loaves just based on 6 days of feeding my starter. The same flour and water, I just changed the feeding ratios and the feeding interval, and I transformed this starter into something completely different and better than what I had before. Actually relabeled it now. This is Cali 2.0 because this is acting completely different than the prior version of this starter, even though it's the same thing, just with a different feeding schedule. The second thing is that we proved that you can adjust your bulk fermentation times by adjusting your leaven percentages with no material impact on the look of the bread. You can get a perfectly proofed loaf with 30% leaven and a perfectly proofed loaf with 5% leaven. You just have to cut it off at the right time. You can't watch the clock. You have to look for the other variables. So this is another good test of the bulkomatic system because we proved now that that really works over a wide range of bulk fermentation times and all different types of scenarios. So I'm really happy with what we learned there. The third thing is that the difference between a weak leaven and a strong leaven influences a lot of the outcome of your loaf. When I compare the loaves in episode 5 versus episode 6, what we just did here, it's kind of mind-boggling to me because this was such a highly controlled experiment. I did the same experiment 7 days apart, and I did it exactly the same way. There were literally no other variables that could have changed here. Temperature was the same, the flour was the same, my tap water is the same that I used a week ago. So this isn't like trying to compare two different bakers' experiences. This was literally holding every variable constant with the exception of the strength of my starter. It's not even a different starter, it's just stronger. It changed everything. I'm actually kind of blown away by what I learned here today. And I realized how many people, including myself, toil away in quiet desperation with a weak starter, trying to figure out what's wrong with their baking when it's all right here. It's just like on The Wizard of Oz. It was right before your eyes the whole time. The answer was right here. I just had to take care of the starter. I had to give this a little time, a little care and feeding. This has transformed my baking, what I've learned here in the last 2 days. Extraordinary. I hope you enjoyed this video. I certainly enjoyed making it. I hope that I redeemed myself in the eyes of my hypercritical board of directors. My starter is reborn, and I'm looking to future bakes with my new baking partner here. Good luck on your sourdough journey. Now I am going to eat some bread.